So good morning everyone, and now our topic is about immunostimulants. So recently we have seen about the immunosuppressants. What are those immunosuppressants? So those are the drugs which suppresses the immune system. Okay, either they can decrease the activity of T cells or B cells or any of the immunocomponents. But here coming to the immunostimulants, so they will stimulate the components of the immune system. So immunosuppressants, they will suppress the components of the immune system, and here these immunostimulants, they will stimulate the components of the immune system, or they will activate either B cell or T cell and both. So these immunostimulants are also known as immunostimulators. So for example of one of the immunostimulant is granulocyte macrophage colony stimulant factor. And we will see some of the examples of these immunostimulants. So some of the examples of these immunostimulants includes levamisole, thalidomide, BCG and other vaccines, as well as recombinant cytokines, interferons, interleukins and various other chemical mediators, as well as coming to immunization. So this immunization can also be provided by using vaccines, immunoglobulins as well as RHO immune globulin. So first one, levamisole, and this drug is also known as tetramizole. So generally it is a L isomer of tetramizole. So this levamisole, it is the orally active levo isomer of this tetramizole, and coming to its action, coming to its uses, so it can be used in the conditions of malignancies, ulcers, herpes virus conditions, as well as in rheumatoid arthritis conditions. So coming to the MOA of this tetramizole, it acts by increasing the cyclic GMP levels. See what is the function of these cyclic GMP levels according to this immune system. So generally this cyclic GMP will causes the proliferation of these lymphocytes. Okay, so these drugs like tetramizole or levamisole will stimulate or will increase the levels of cyclic GMP. It also decreases the metabolic inactivation, or this drug will inhibit the metabolic inactivation of cyclic GMP and will increases the levels of cyclic GMP. So if cyclic GMP levels are increased, so it can proliferate the lymphocytes. And if lymphocytes are proliferated, they can produce the immune responses. Like that, they will stimulate the immune system, and that can lead to production of antibodies as well as lymphokines and increased phagocytosis process. So all this process will stimulate the immune responses. And next drug is thalidomide, and it comes under a class of anxiolytic, antiemetic, as well as it has anti-inflammatory properties, and it is also a cytokine modulator. And coming to the MOA of this thalidomide, it will increase the T cell production. Okay, so it will increase the T cell production of various cytokines. So generally it will stimulate the T cells, and that leads to the production of various cytokines like interleukin 2, interferon or gamma and natural killer cells, which is mediated by the cytotoxicity induced tumor cells. And next, coming to the use of this drug like thalidomide, it can be used in the conditions of multiple myeloma. Again I am saying, so this thalidomide drug has the property of as you see this anxiolytic property and antiemetic property, and it also have the anti-inflammatory property. So the MOA of this thalidomide is it increases the production of T cell. Okay, that means it increases the production of T cell mediated cytokines like interferons or IL-2, interferons like interleukin 2 or interleukins like interleukin 2 and IFN and natural killer cells. Coming to the uses, so it includes multiple myeloma. So in this condition, this thalidomide can be given. So this drug also leads to it has a mystery like it leads to phocomelia, that means sealed limbs. So generally at that in the previous years or in the olden days, so this drug was given to the pregnant women. There it results in the teratogenicity, and not only that, it also results in various deformities in the mainly in the limb region. So now also the persons who taken this drug, means now also the child was suffering with that syndrome because of this drug. So next is known as BCG, that is you all know that Bacillus calmette-guerin vaccine. So it is a enhancer of the immune system, and it also stimulates the immune responses. And it contains, means the vaccine BCG contains residue like the its methanolic residue contains a peptide known as muramyl dipeptide, and that is known as that is a immunostimulant. And this muramyl, if you see this muramyl dipeptide, it has an active immunostimulant activity. And for these BCG vaccines, the T cells, they are the T lymphocytes, they are the target cells. And coming to the activities of that, so this BCG vaccine also induces the production of lymphocytes, and it can leads to the, means it can produce various immune responses. Again I am saying, so the BCG vaccine, so BCG vaccine means Bacillus calmette-guerin. So its methanolic extract residue of this BCG contains a peptide known as muramyl dipeptide, and that muramyl dipeptide is a immunostimulant, and it also leads to production of various T cells and produce immune responses. Like that, it can stimulate the immune system. And next one is interferons. So these will be produced in the conditions of infections. So whenever there is an infection, so these interferons will be produced by the host cells. So these are nothing but a kind of cytokines or chemical mediators. So generally there are three types of interferons, like alpha, beta and gamma. So they inhibit, means what is the MOA of these interferons is, they will inhibit the multiplication of DNA proliferative properties. And interferons are a kind of cytokines, and they will be produced in the conditions of infections. And coming to the adverse effects, they include myelosuppression and hypertension, arrhythmias, alopecia, that is loss of hair, headache, and arthralgia, that is pain in joints. And it can also causes neurotoxicity, which result in it also results in confusion, sedation, and seizures also sometimes. So interferons, they are nothing but the cytokines which are produced by the host cells whenever there is a condition of infection. So coming to the adverse effects, so it includes like myelosuppression, hypertension, arrhythmias, alopecia, headache, and not only that, it also results in sedation and confusion as well as arthralgia conditions. Sometimes it can also cause the seizures. And next one is viral vaccines. So most of us are aware of these vaccines. So these vaccine means viral vaccine generally contains a live or dead virus. So live virus means it is weakened, it is in weakened state and it won't get replicated. So generally the vaccine contains either live, that is attenuated, or dead virus. Attenuated virus in the sense that means it is live virus but it can't replicate or it won't produce any kind of pathogenic infections. So whenever this vaccine is administered to the humans, what happens? So that human immune system will produce antibodies towards that particular virus. So whenever the disease is going to encounter in future, so the antibodies are ready in that host body, so they will combat the antigens or any virus. So generally viral vaccine contains a live or dead virus cells. Live virus in the sense, so that virus is inactive, that means it is not that much active to be pathogenic or to cause any infections. So whenever the vaccine is injected or whenever the vaccine is administered into the body, so what happens, the immune system will produce antibodies towards that towards that vaccine or towards that virus organism. So whenever the disease which is caused by that particular virus is encountered in the future, so there will be antibodies in our body. So that antibodies which is already existed will combat that antigen. So like that it can produce the immunity. So coming to the side effects of these viral vaccines, they include blood in the urine or stool, as well as pneumonia conditions and inflammation in the stomach or intestines. So these are the adverse effects or side effects. So last one is colony stimulating factor. So these colony stimulating factors will be induced for the patients in which the white blood cell count is very low. That means in the conditions of neutropenia, so these colony stimulating factors will be given. So what is this colony stimulating factor and what is it used means? So these are nothing but a glycoproteins, but they can lead to the production of WBCs. So whenever there is a condition of neutropenia in most of the diseases, so these colony stimulating factors will be given to that person. So these colony stimulating factors will increase the production of WBCs in response to the infection, and it also stimulates the stem cells in the bone marrow in order to produce the WBCs. So this is the MOA of this colony stimulating factor, and this is all about the immunostimulants.